Welcome to another lecture of our DBMS playlist. Today we are going to learn third normal form or 3NF. So what are the conditions of being in a 3NF? The table must be already in 2NF. Okay, so and how can we detect that if a table is in 2NF or not? I have already discussed that in my previous video. So go check it. And so the condition for a table to be in 3NF is that it must be in 2NF, and the second condition is there should be no transitive dependency. Okay, so in the table there should be no transitive dependency. So what is transitive dependency? I have already told you that in my previous video, so you can check it from there for better explanation. I am just saying it in short here. That is, if a non-prime attribute is determining another non-prime attribute, then we can say that this is a transitive dependency. Okay, so if any of the functional dependencies have this type of dependency, like a non-prime attribute is depending on another non-prime attribute, then we can say that this FD is transitive dependency, and then this relation is not in 3NF. Okay, so now let's check an example. Suppose there is a table with roll number, city and state, these three attributes, and roll number is our primary key here, or you can say that it is our candidate key, whatever. So whenever you can check from the table that the value of state depends on the roll number, but also the value of the state depends on the city, because whenever we are having city as Mohali, we are having state as Punjab. Okay, so this means that city can define state. So with the what are the functional dependencies here? That roll numbers can define city and city can define state. These are the two functional dependencies in our table. Okay, so let's check if it is in 3NF or not. So see, the candidate key is roll number. So what is the prime attribute? It is roll number, and the non-prime attributes are city and state. So for this particular functional dependency, that is city defining state, okay, so this is a transitive dependency. How can we know that? Because this city is also non-prime attribute and state is also a non-prime attribute. So non-prime attribute is defining another non-prime attribute. So this means this city defining state is a transitive dependency. So this whole table is not in third normal form or 3NF. Okay. So for each functional dependency, the left hand side must be a candidate key or a super key, or the right hand side must be a prime attribute. So if any of these two conditions is true, then we can say that there is a transitive dependency. Okay, so what are the rules? The left hand side must be a candidate key or a super key, or the right hand side must be a prime attribute. Okay, so if these two rules are true, then any of these two rules, because we are having or between them, so if any of these two rules are true or is true, or both can also be true, so if any one of these two rules or both is true, then we can say that the table is having zero transitive dependencies, so it is in 3NF. So let's check it with an example. So there is a table with attributes A, B, C, D, and functional dependencies A, B defining C, D, and D defining A. So here we are having which attribute we do not have on the right hand side. We do not have B on the right hand side. So we know that the candidate key must contain B along with something else, because B's closure only will give us B. So let's check AB's closure. So AB's closure is giving us all the attributes A, B, C, D. So we can see that AB is our candidate key. So our prime attributes are A and B, and non-prime attributes are C and D. So we can say one functional dependency here, A and B, this is our candidate key. So this is on the left hand side. So this condition satisfies. So this is not this FD is not a transitive dependency. Now check for the next FD. So D determines A. So D is not a candidate key or not a super key, but A is a prime attribute. So if right hand side is true, so this means we have a transitive dependency. So this means that, so D determines A here. See, the left hand side is not a candidate key or super key. So this rule is not satisfying here, but the right hand side is a prime attribute, so this is satisfying. So as we are having a OR here, so this means if any of these two is true, then we don't have any transitive dependencies. So D defining A is not a transitive dependency, so we can say that any of the FDs are not a transitive dependency, so this table is in 3NF. Okay, so the answer is correct, but is our approach correct? No, because what I have already said you, we have to always check for all the possible candidate keys. Okay, so AB is not the only candidate key possible here. So as I have already taught you in my video where how to find candidate key, so see, AB is our candidate key, that is correct. Okay, so we have our first candidate key. Now I have said that we have to check that if either A or B is on the right hand side of any functional dependency. So see, we have D defining A, so this means A is on the right hand side of this functional dependency. So then I can substitute A with D, because D can define A, so then DB also can define AB, so DB will also be our candidate key. So let's check it. DB's closure is what? DB can determine DB itself, also D can determine A, and AB together can determine CD, so C is also defined. So this is also our candidate key. Okay, so the answer is correct, there will be no problem with that. Okay, there will be only another prime attribute in our list, that is D is also going to be our prime attribute. Okay, so non-prime attribute only will be C, so this is going to be same. Okay, so this is in 3NF.